zeros are, and you should know that zeros are the same things as roots or solutions. Okay, we say them in different situations. If you are solving an equation, then obviously you're going to have a solution to that equation. When they give you something and it's like set equal to 0 and they say find the zeros, you're also looking for the solutions. When they ask you to find the roots, they're usually referring to a polynomial function. So, or it doesn't even have to be a polynomial function, just in this chapter. So they'll say something like find the roots of the function, and those mean the same thing as the zeros. So this first question says find the zeros. So in order for you to find the zeros, there needs to be some sort of zero in the question. If you have a y or an f of x, you're going to turn that y or f of x into a 0. And you're going to have, we have 3 factors. So it's already factored for us, which makes this really easy. So you're going to have 3 factors that are multiplied together and set equal to 0. Now, what is the property that allows us to take each one and set it equal to 0? Right. Zero product property. So the zero product property says I can take all of these factors, set them equal to 0, and solve. And when you do that, you get -2, 1, and 3. And that's it. Now, obviously, they're not all going to be like factored for you, nice and tidy. So we will be working during this chapter on how to solve them when they're not factored or when they're not factorable. That's what we'll be doing in the later sections. But until then, we make it easy. Some new skills about using the graphing calculator. So on your graphing calculator, you're going to graph this function. So open a new document of graphs and type in the cubic, so x cubed plus 3x squared minus 24. Okay, and we are going to find any zeros, the maximum, and the minimum, if there are any. So keep in mind that not all functions have zeros, not all functions have a maximum, and not all functions have a minimum.
What if it's too small for you to see? How do you zoom?
That's what I'm going to teach you. Don't zoom. Do not zoom. You're going to wreck it. Alright. When you zoom out of anything, what happens?
It gets smaller.
It gets smaller. What happens if you zoom out a lot?
Then you can't see it.
Exactly. If you're in a plane and there's a turtle down there, can you see the turtle?
No.
No. And what if we want to see the turtle? Yeah,
We have
right.
to get closer.
Yes.
Or we have to use an
So
microscope.
we don't want to just zoom out until we can't see the turtle anymore. We want to strategically look at the graph so that we can see all of its pieces. Now, one of the things it wants us to find is the 0. Can we see the 0?
Now.
Yeah, we can. It's right there. So let's find that first. So you're going to go to Menu,
6.
Analyze Graph,
0.
0.
That's how we literally take doubles in this house, guys. That's it.
Now, all cubics will have at least one 0 that is real. Okay, sometimes there are non-real.
0 would just be 2.16.
Yep, comma 0. Okay, and depending on the humps, it could come back and hit it again, up to 3 times. But at least once. So if you don't see it, that means it's not in your window. You have to find it. All right, so there are different ways that you can view more of the graph, but you need to know in general this is a positive cubic. So if this is a positive cubic, do you see how it's kind of like drifting to the right?
Yeah.
So this is the right side of the cubic because it's drifting to the right, which means this is up and going to keep going up, and it means the rest of this cubic is somewhere down here that we can't see. Okay, so you know that because it's going up and to the right because it's a positive cubic. So we need to scoot this down a little bit, and you can try, before zooming out, to just control and then click, and you can try just scooting it.
Hold on the middle button. do it.
Hold down the middle button.
Like hold down the middle button and the hand will appear.
Oh, I see what you're saying. Yeah. Now, this is a good technique if you can get down there quickly and see it. But if you can't, then maybe this isn't the best way.
I found the hump.
You found it, so you just kept going.
The hump.
Now, another way you can do it. So, ready? I'm going to show you another way. If you go to menu
Menu.
and you go to window and zoom,
Zoom.
you have a lot of options here. So let me just go through a couple of options. Zoom in and zoom out are common sense. Zoom standard will bring you back to the default, like the original image. So let's say you accidentally zoomed out a lot and you like can't see the turtle, then you can go back to zoom standard. It'll bring you back to the beginning. You can try again. Zoom quadrant 1 is kind of common sense. That'll bring you to quadrant 1 only. We're not going to use most of these in this particular class. Zoom fit is worth a try. It'll try to like give you what the calculator thinks is the best view of the graph. It doesn't always work. It's not helpful for min and max usually because it'll zoom in too much and then you can't see the humps. So we're not going to do that either. If you look at the very first one, it says window settings. So window settings is a way to adjust the window itself. So that is basically like where you're looking at the graph. So right now on my window settings go from -9 to +10. Now I might want to keep that. Those are my X, min, and max. I'm gonna just leave that alone, but I could probably bring it in a little bit because I don't need maybe all of that range. Like I don't need it to go all the way across.
Cool.
What we are mainly focused on is the X min because we're not low enough yet, right? We need to go down faster. So where do you think it is?
20.
Well, I know you mean negative.
Negative.
We're going to try -30. The reason we're going to try -30 is if you were to find the the y-intercept of this graph by plugging in zeros, the y-intercept is -24. So it's down there. Most of the action is low. So if I make the y min -30, I can keep my y max where it is, or I can scoot it down a little bit since there's not really much happening where it is. And then if you press enter, you'll see you get a nice little view of the curve. So it scooted it down for you instead of just having to go like blah, 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 blah. And now we can see the max and the min. Okay, so now you can find them. So go menu, analyze graph, and we'll find the maximum first. So maximums over here, we're going to bring the dotted line somewhere to the left of the hump and click. And then we're going to bring it across the maximum. Okay, and it's going to highlight the maximum in gray. As you do these, sometimes the text will get in the way. Okay, you can move the text out of the way. You can practice that. This guy might be in the way. You want to move him. Like Andrew said, you could click and hold or control click.
We only take dubs in this house, guys.
Okay, then we're going to find our minimum. So menu, analyze graph, minimum. This is our minimum, so we want to bring this dotted line somewhere to the left of the minimum. Click, and then drag it over to the right. And so I got
0, -24.
0 and -24. Keep in mind they won't always be like nice numbers. They might be decimals, and your calculator's going around. You'll just take those. Okay. Questions.
Why are we alive?
What is the meaning of life?
With
Okay. If they give you the zeros, -2, 1, and 3, what factors would these have had to come from in order to, if we set it equal to 0, we would have gotten these numbers?
F of x equals
2.
x plus 2.
Okay.
X minus 1, X minus 3.
First problem.
Actually, you can put them, multiply them together.
So what's the relationship here
They're all
between the factor and the 0?
they change the sign.
it's just change.
Yeah,
the
they just
sign.
changed the sign. Okay, so now, well, no, those are the factors. Okay, so the factors come from the function. The opposite of factoring is what?
Oh.
Yeah.
foiling.
Multiplying and or foiling. We use the cutesy little
With the
foil.
We had the triple foil?
Triple foil.
Man, let's go.
In
X-
order
X
in order for this
cubed.
to be a function, what is this equal to?
X. F of X.
Either f of x or y. Okay? Because it's a function.
All right. So X cubed.
So we're gonna first
Some real spaghetti.
foil this. So x times x is x squared. X times -1 is negative x. 2 times x is 2x. 2 times -1 is...
-2.
Okay, that is the product of the first two factors. Before going on to the next thing, I recommend simplifying.
We got from Chief.
Okay, so combine the two middle terms. Okay, so now once you've done that, now you can do it again.
Again.
So we're gonna foil again.
No.
So using the purple product, we're gonna foil with this guy. So x times x squared is,
Against foil.
okay,
This is ridiculous.
Oh,
I'm gonna color code everything. Okay, then we got x squared times -3, which is,
Negative 3x squared.
then we have to do x times x,
X squared.
good. Then we have to do
Negative 3x.
x times -3,
Negative 3x.
okay, then we gotta do
Blue.
2 and, or -2 and x.
Negative 2x.
And then last but not least, we do,
-2 and -3.
right. Okay, now of all of those, can we simplify?
Yeah.
Is that the same order of arrangement? What's the order of arrangement?
Yeah, it is. I don't just randomly pick colors, child.
I
Alright, so
know,
we
but-
can combine these two, and that'll make what?
Minus 2x squared minus x plus 6.
Good. Yeah, what kind of rookie do you think I am? And then what is this equal to?
F of X.
Yep, or,
Y.
yeah.
Tell me.
Why? This is rep. Why?
F of X.
Okay, so my suggestion is to take these two first
Foil.
and foil because they give you another binomial,
Been foiled.
okay? So that's my suggestion.
I used to say their plane got foiled.
And then you can take these two and foil, and you get x cubed minus 3x squared minus x plus 3. And then after that, then you can just basically put in an extra x into everything. So x to the 4th minus 3x cubed minus x squared
Hold on, you're going
plus
pretty speedy.
3x.
It's like Speedy
I was about to
Gonzales.
leave it as X and then parentheses whatever, and then I read the directions again. I was like, ooh, quartic.
Quartic, so you should get x to the 4th, yeah. So if you don't do it this way, you could probably still get the answer. If you did it a different way and you got the same answer, then you've discovered that already. But I think as far as like doing less foiling, I think this is the fastest way to do it.
So you foil the first two, and then you take that foil and foil it again.
Yeah, and then you do this.
And then you do, okay.
I just put it at the end because it's like one less thing I have to write in each step. But it's not really like, it doesn't matter. So what property allows us to do this in whatever order we want?
The distributive property.
No.
Commutation property.
No. The commutative property.
PEMDAS.
You mean GEMDAS?
No, Commutative property she of didn't say multiplication. that. She
Yes.
said commutative.
Commutative property allows us to do this in whatever order we want.
Punitive property of what?
Okay, let's look at the extra examples I have over here.
Division, subtraction,
There's
multiplication.
no
Oh, I
division.
already wrote
Don't
example
care.
4.
Put this on the back.
What?
I
What?
Clicky up.
got what you're
Mine's double
My
sided.
grade. I don't know.
Zach.
Let me think about that.
Put it on a separate sheet of paper.
I got A plus.
Separate sheet of paper?
In order for us to have the zeros the square root of 3 and the negative square root of 3,
We got a problem.
I refuse to have that.
then that means that came from us using the square root property. So that means we squared both sides. Okay, so we would have squared, or we would have square rooted both sides. And since the square root of 3 squared is 3, that means it came from this step. Okay, and you can check real quick, if you square root both sides, do you get the square root of 3? Yes, you do.
So x squared minus 0 is x.
So
Okay, and then that means that it would have come from x squared minus 3 equals 0 before that. So that would be our first factor, is x squared minus 3. And then this one's easy, right? That one's just x minus 2. Okay, in order for this to be a cubic function, what does this have to be equal to?
Y or f of x?
Y or f of x?
wait, why didn't you use -3?
What?
Oh, I see, Coach.
I don't see
What?
zeros. You did root 3. You did negative root
There, when you use the square root property, that's why you put the plus or minus in there, because you get both of them. I don't need to do one for root 3 and negative root 3. They came from the same
Thing. So
thing.
this is-
This counts as 2. This has 2 roots.
Imagine.
Okay, so we're going to FOIL this out.
So x cubed
X squared times x is x cubed.
Cubed
And
minus 2x squared
minus
Yes.
squared
minus 3x
minus
plus 6.
Yes.
Okay.
That's what I call a victory.
Is there anything we can simplify?
Oh, we need
No.
blue and we
No.
need purple.
Oh, I ran out of terms, so I don't have any
Just
blue
use
and
the
purple.
equal sign. F of x is red. Equal sign is orange. Everything else is in the
Is it
center
bothering
quadrant. It is.
So x squared times x is x cubed. X squared times 4. Negative 4x squared. 1 times x is x. 1 times negative 4 is negative 4. That's your cubic.
That's good. We don't take Dublin's house.
Would you be wrong if you went halfway through?
You don't have to draw it well. Alright, so it says the design of a box
I'm right here.
I miss Christine.
maximizes
Remember?
volume.
She dated Alex Fisher.
That's wrong.
Oh my god, that's funny. Remember when she
That
asked
is
Luke?
really
Remember when she asked Luke to ask her out and then he did?
What?
He told her
Andrew!
every week. Huh?
Shh.
Sorry, Coach.
Okay.
That one never happens.
This is a box. We want it to have the maximum value. How do we find maximums? How do we do it? How have we been doing it?
Menu, 6,
maximum.
3.
Yeah. Menu, analyze graph,
6,
maximum.
4.
So what we need to do
It's
is we need a function that we can plug into our calculator
Yo, I got that right.
to find the maximum. Now, that's harder than it sounds. Okay, we have to come up with the function. So here's how we're going to do it.
Half of x.
This is a box. What are the dimensions of the box in general? General dimensions.
X, X, X.
This is a
Length, width, and height.
Oh.
Okay. And how do we find volume of the box?
LW.
Length times width times height. Aesthetic.
Good. Now, can we type this in on our calculator?
Oh.
No.
Yes, actually.
Okay.
we can.
The only letter we can type in is X, and there's other letters up here, okay? So we need to type in something that's all one letter, first of all, and then we're going to make it the letter X. Now, it tells you in the question a few things. It says
Height.
the sum of the dimensions is 6 inches. Okay, so I'm going to write that down. The sum of L, H, and W is 6.
You ready? You ready for this? If the height is 1.5, that's a square. So width is also 1.5. And length is 3.
That's not how that
That's
works.
that's a hypotenuse thing, bro.
It's a hypothesis.
Okay, in addition to that, it says the length must be 1.5 times the height. If I had to write that as an equation, what would it be?
Length must be
1.5
1.5. So L
1.5.
equals 1.5 H.
There you go.
Wow.
That is a 1, not an L. I'm going to write.
Sorry, I had it in cursive.
Yeah.
Maybe
Whatever.
you didn't look at your
That's
phone
a
so much, it
personal
wouldn't hurt
issue.
as much.
There you go. Better.
That is better.
You should look at your phone. Maybe that's why you're
So now it looks weird.
You're just.
Listen, but now
Alright.
we can differentiate. It's a pen.
So what we have here is we have L written in terms of H. That's helpful. I'm going to take this and I'm going to put it in here. So instead of L, I have 1.5H. Now I also have a W and an H. So the next thing I need to take care of is this W.
We go
I need it to look like an
We
H.
gotta get the dub.
To do that, you're going to do two things.
You gotta get the victory royal.
The first thing you're going to do is take this and plug it in here.
Oh, no.
I was right.
Wow.
So we have 1.5H
No, don't do it.
plus H plus W equals 6.
So we're doing substitution.
We are doing substitution. That's how we take multivariable things and make them less variables or fewer variables, is substitution. Okay, I'm going to combine these two. So 1.5H and H is going to be 2.5.
Oh, you're smart, Shay.
Minus 2.5.
There you go. And so then I want W in terms of H. I'm going to subtract 2.5H.
W equals 2.5.
Okay, now what should I do with this?
Plug it in.
Where?
Wait,
That
isn't it
one.
technically
For W.
2.5?
Yeah, for that one.
Wouldn't W
This is
equal
silly.
2.5H?
What?
Like, do you still need to put H for 6.5? Don't you still
Dang.
need to do that?
Oh, sorry, the H. That's what
Yeah.
you're saying.
That's
yeah.
what I was saying.
Yeah. I forgot the H. You said it so fast that I was like, what are you saying?
I don't know what I'm saying. Miss Red.
Yes.
No.
Would you be up for a quick GN segment?
Actually,
So just turn all your H's into X's. Okay?
Plug what?
Your calculator will graph almost all of this. You don't have to simplify it completely, but you do have to simplify a little bit. It gets confused. You don't have to actually. You just have to combine like these two. It gets confused when you have more than 1 times X for some reason. Okay, but you could type this in, but it just can't do it with like 2 regular X's. It'll say, I don't know what it says.
It's like error.
Yeah,
Syntax error 404.
Yeah.
you made that up.
No, he typed it in.
I mean,
Oh.
the calculators.
No, I-
I'll see what it says. Let's see.
I made the 404 up, but the syntax error is right.
It says cannot accept change input, invalid input.
Okay,
Okay, Kyrie.
So you got to simplify a little bit.
I refuse.
Does it take credit card?
Let's take debit.
Okay,
Debit or credit?
what are we looking for on our graph?
Maximum.
Maximum.
Can I see the maximum?
No.
Is it too high or too low?
Too high.
Okay,
Hot damn.
I'm going to go menu. I'm going to go to Windows Zoom, Windows settings.
Literally
Damn.
do the little mouse thing.
Yeah, you could. I'm just going to increase this a little bit. There you go. Now we do what?
We
Menu.
6-4.
3.
6-4. Ah, 6-3.
It's maximum 3.
It's
Okay. A little bit over here,
a little bit over
a little
there,
bit over there.
a little bit right
Okay,
there.
so it gives me this point. What is this point?
It is your maximum.
What is it in context of this box?
X.
Height, length, height, width, the dimensions.
It's not all the dimensions.
It is W.
What letter
Volume
on the
is
coordinate
height.
plane is this?
X.
Something.
Okay, and what is x?
Height.
Length.
Okay, so the height is 1.6.
Oh.
Now, what is this?
This would be Y.
What is y in our question?
Volume.
Yeah. So that would be the maximum volume.
Okay. Oof. Didn't think.
Now, does it want the volume?
No, once.
Yes. Wait.
No, it wants each dimension. So, to find the length, you're going to take 1.5 and multiply by 1.6.
Oh my gosh.
It's 2.4.
How are we supposed to like remember all this, yo?
I know.
'Cause
Cry.
it's asking for the dimensions, and you know what the dimensions are in terms of h, so you're just plugging them back in. Remember when you solve systems of equations, you solve and then you plug stuff back in. How do we find W?
Six minus 2.58.
Yeah, you just plug them in here.
Or you could do 2.5, 1. That's a big number. Select video.
I got 2.
P2B number 1. Yeah.
Wait, how'd you get 2 for the? Oh, I see.
Yeah, do it.
What'd you get?
You
6
don't have to plug it in.
Mhm.
You can just
H.
add those two and then it works.
So you have a rectangular piece of metal. It is 16 by 12 inches. We are cutting little squares out of the corners so that we can turn it into a box.
Wow.
Okay. Do we know how big those squares are? Does the metal worker know how big the squares are? No. So when we don't know stuff in math, what do?
Yes.
X.
Draw it.
Yeah, we guess. No, we use a variable, right? X. So what would the dimensions of these little squares be?
X.
X by,
X.
and how do you know both of them are X?
Because you don't know
A
both.
square.
Because you know what a square is. Yeah? So all of these are X by X. Okay, and we folded it up to make this box. I'm going to draw a picture of my box. Mirror, 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 mirror.
I won't hear you.
I'm tired.
My tired, nice to meet you.
What's up?
Hey.
That's not funny.
That was a good one, right?
You're not funny. Okay, so open top box.
That's funny. I was laughing at boxes.
All right, so we need to know what the dimensions of this box are. Now,
None yet.
this is this piece of the box.
You take your phone.
Shh, look. Look. This is this part of the box. It's the length of my box. If it was 16 and I cut little tiny pieces out, yes. So do you see how I cut this piece out and this is X long? And I cut this out and this is X long? You see that? So this red piece is 16 minus 2 X's because I cut the 2 X's out.
So then the other side is 12 minus 2x.
That is a good guess.
Oh my
So
God.
on this side,
It's an abomination.
this is the length of my box. And I also cut little squares out of this, yeah? How many squares did I cut?
2.
2. So this is going to be 12 minus
Avoid
2x.
execution.
Yo, where were you dropping?
Where were you drawing?
You didn't even notice that?
What?
Oh,
You know the
and it was
pumpkin
the
head?
animal and his pumpkin hat.
There he is.
And then, what is the height of my box?
X.
Good. The height of my box is x because I would have folded it up here. Remember, I folded it up, and I folded it up using the dimensions of
Is there gonna be a
the
word problem in the
squares that I cut out. No, but it'll be on the test.
That's
Okay.
Okay, test is for free.
You see that? So x is my height. So how do we find volume?
Length times width times height.
Okay, and we want the maximum volume. Can you handle it from here?
So 16 minus 2x times math.
All right, so it tells me 2.26 and 194 is my maximum. Now, what does the question want you to find?
It wants you to find if you move the calculator the maximum volume of this box.
Does either one of these represent the maximum volume of the box?
Chrissy, where are your phone?
Yeah, the Y, 194.
We know 90.
So 194 cubic inches is the maximum volume of this box. Question. First thing you're going to do if you're finding zeros is you're going to let your Y be 0. Or if it's an f of x, you're going to let that be 0.
Uh-oh.
My bad. Okay, and then for all these questions, because we're still in section 2, we should be able to factor out a greatest common factor.
X squared.
Okay. So that would leave us with x squared minus 2x minus 8 if we take out an x squared. Then we're going to take the x squared and set it equal to 0. And we're also going to take the x squared minus 2x minus 8 and set it equal to 0. Okay.
And you can use like you can factor that out, right?
We can factor this out to x minus 4 and x plus 2. So I get x equals 4 and x equals negative 1. Now I only got those once, so each of those would have a multiplicity of 1. Okay, but over here where it says x squared equals 0, I'd get,
2.
right, x equals 0 with a multiplicity of 2. So that's where multiplicity comes in, because it's x squared, and technically I could rewrite this to x times x equals 0, giving me 0 twice. Okay, but that's kind of obnoxious. I don't need to do that, but that's what the multiplicity means.